In this video, I would like to show you how to connect and how to use the cluster. First, connect to the cluster using your login. In my case, it is SSH LCL _ University of Toronto BioD25 student 1917 at teach.signet.utoronto.ca. Next, you enter your password, which will not appear on screen. And if you did not make a typo, you will be greeted with the usual welcome page of the Signet Teach cluster. The first thing we do is we check where we are with the command pwd, present working directory. You can see that this points to a path that starts with the directory /home. We are going to change directory with the command cd $scratch. The path changes and now points to a directory that starts with /scratch. We can inspect the content of the Scratch directory with ls, which is empty, so nothing appears in output. Before we go further, let us review the architecture of the computer cluster. When you use SSH to connect from your computer to the Teach cluster, you arrive on a computer that is called Teach01. Using a language that is called Slurm, we then delegate the computations to more powerful computers that are called compute nodes. Computations are carried out on compute nodes because the entry node Teach01 does not have enough computing power to process all our requests. Back to the command line interface, we copy the data from its source with the command cp /home/g/gfilion again /dml-all-transcript-r636.fasta space dot. The dot indicates the destination, which is the present working directory. We then use the command ls to make sure that the file has been copied. We can also use the command ls-l to show more information about the file, including its size. Say the file is too large and we want to compress it. We will copy a Slurm script that does exactly that. We use the command cp /home/g/gfilion again /compress.slurm space dot. With the command ls, we can check that the file has been copied. Let us now inspect the content of the file with the command less compress.slurm. The first line indicates the language of the script. The second line is the command that requests the host name of the computer, and the third line is the one that actually requests the compression. We press Q to exit the viewer, and before we submit the script, let's use the command hostname. The output is teach01.signet.local, confirming that we work on the computer Teach01. We now submit the script with the command sbatch compress.slurm. We obtain a job ID, which in this case is 202028. We can also check the status of the script with the command sq. You can see the job ID here along with additional information. If we use the command ls, we see that two new files have appeared. After a while, the command sq shows that the job ID has disappeared, meaning that the run is finished. The command ls-l shows that the FASTA file has been replaced by the compressed version. The extra file contains the output of the command hostname that was run in the script. We can view it with the command less, and we see that the script was run on the computer Teach35. An important thing to know about the cluster is that the Teach01 computer can write everywhere, but the compute nodes can write only on Scratch. The directory home is for permanent storage. Files in the directory Scratch are deleted after a few months of inactivity. The compute nodes write to Scratch only in order to avoid saturating data storage. Since we will need Signet only a few weeks, we will do everything on Scratch. If you forget the command cd scratch at the beginning of your session, you will get an error when you submit the Slurm script. The error explains that the directory is read-only and that the script was not submitted. There is of course more to say about Slurm, but that's all you need to get started. For more information, please visit the help page linked in the description.